Last video, I showcased how to host Elasticsearch locally and use it for your Flutter application. In this video, we will host Elasticsearch on the Google Cloud platform, send data using Google Cloud Functions, and implement a suggestion search feature for our Flutter application. Just like my last video, I told you that Elasticsearch needs a place to run. This could be on a local server or on a cloud platform like Google or AWS. To get started, you'll need a Gmail account and an Elastic account. Go to the link in the description below and register for the Elasticsearch 14-day trial using your Gmail account. After this, we verify some information and deploy our Elasticsearch server. There are different keys I advise we copy before doing anything. These values would be used to query the Elasticsearch in some way. Copy and save the following values: the Cloud ID, the Elasticsearch endpoint, the Kibana endpoint, and the Enterprise Search endpoint. After this, we can take the Elasticsearch endpoint and post it in our search bar. Remember that the endpoint of the Elasticsearch server is just the location of the server. As you can see, we are being asked for a username and a password. This is because Elastic wants to make sure anyone that knows the endpoint cannot just query our server. To get the password and username, go to the Security tab and click the Reset Password button. You would be provided the username and password for your Elasticsearch endpoint. After taking the username and the password, you can take them to the Elasticsearch endpoint and then post them there. This will allow you get into the Elasticsearch server. Now that we have Elasticsearch running on the cloud, we can use Kibana to visualize all the data. We do the same thing. We copy the Kibana endpoint we found earlier and we post it in our search bar. We would use the same username and password we used earlier to log into Kibana. Before I explain how to send Firebase data to Elasticsearch, let me explain how we would create the Autocompletion System. In Kibana, go to the top left bar, scroll to the management section, and there you will see DevTools. Here we can play around with our queries. So Elasticsearch stores its data in something called an index, and each index has some type that contains several data. Right now we would create a new index and let's name it locations. Using the put HTTP method, we would give this index specific map settings for its city data type. For this particular search, I would be using something called n-grams. Basically what it does is that for every city we have in our index, it would split the city into several characters. And using these characters, we can find the right information that corresponds to any n-gram. There are tons of other ways to create an autocomplete system in Elasticsearch, and this is the beauty of the Elastic Stack. Please check the description below for an article that would help you better understand these other techniques. If you get confused, all the Kibana requests will be on my GitHub for you to play with. Now using the post HTTP method, I would go ahead and add a bunch of cities in our Elasticsearch server. Now we can use the get HTTP method to query our database and ask it to suggest some cities to us. As you can see in our response, we actually get the right suggestions just by giving it some prefixes. We need to get our Firebase data to our Elasticsearch server for indexing. Two ways to send your Firebase data to Elasticsearch are using the Google Cloud Functions on the server side or our Flutter application on the client side. Using the Google Cloud Function, when we add some data to Firebase, this data would be sent to Elasticsearch. When some data is updated, it is also updated on Elasticsearch. And when Firebase deletes some data, the data is deleted on Elasticsearch. Let's set up the Cloud Functions quickly. You would need the Blaze plan to use Google Cloud Functions, but do not worry, you won't be charged unless you go over the free Cloud Function usage. To set up Cloud Functions, we click on the Functions tab on the Firebase console page and then click the Get Started button. Here we will get some information on how we should set up Cloud Functions. Because we will be using Node.js and the Node Package Manager to install the Firebase command line tools, we need to get npm. There is a link in the description to download npm and Node.js. The installation process is pretty basic, so I would be skipping that. Once we have npm installed, we open our command line of choice and configure the following. Install the Firebase tools, log into Firebase to access your project, make a directory to store your Cloud Functions, and go to that directory to initiate the project. This will ask us a couple of questions. For my project, I will pick the following options. Yes, I am ready to proceed. Configure and deploy Cloud Functions. Use an existing Cloud Function since I already have one. Pick an existing Firebase project. Choose to use JavaScript, yes to ESLint for debugging, and yes to installing dependencies with npm. After initializing the cloud function, we go to the functions folder directory that just got created by initializing and install the Elasticsearch node.js client. Also, using the Firebase functions config, we can set the Elasticsearch username, the Elasticsearch password, and Elasticsearch URL as an environment variable for our cloud functions. This way, we find an easy way to access the data without having to input it inside the code. You would understand more about this later. Open the cloud function folder in an editor of your choice. Navigate to the index.js file in the functions folder and let's write some code. When a user writes to Firestore, we take that data and put it in Elasticsearch. When a user updates some data in Firestore, we want to update that same data in Elasticsearch. And when a user deletes some data in Firestore, we need to delete that data in Elasticsearch. For this to work, we will create trigger functions that will be invoked when these special operations happen. To get ready, we would use the required keyword to include the Firebase function model, Firebase admin model, and the Elasticsearch client model. We would set up the Elasticsearch authentication variable using the config variables we declared earlier in the terminal. Next, we would get an instance of our Elastic client using our endpoint and the authentication values. We set up the trigger functions and we have to pick the document we want to access. In my case, I have a CTs collection that contains several CTs documents. For the onCreate trigger function, we get the snapshot data from Firestore, and using the Elasticsearch client, we would set the data of the Elasticsearch index. The ID of the snapshot we found will be the ID of the Elasticsearch document, and the snapshot's data will be the body of the Elasticsearch document. We do the exact same for the onUpdate trigger function, but in this case, we want to get the snapshot.after data. The after keyword says give me the changed value, not the previous value, and for the ID, we get the snapshot.after ID, and this is sent to the Elasticsearch index. The last thing is the onDelete trigger function. Get the ID of the deleted snapshot, and then delete the ID from the Elasticsearch index. After this is done, we can deploy this function to our cloud functions by going to our terminal and inputting the following commands. What this command says is, deploy only the functions that were edited. Now that we have our cloud function set up, I can show you that it actually works. So now I'm going to add some data to the Firestore database, and then you can see the same data, I can find them in the Elasticsearch server. So we can see that the data definitely gets sent by using the trigger function. And when I update some data, you can see that that data is also updated. And when I delete some data, you can see that that data is also nowhere to be found. So now we have the cloud function set up, all working perfectly. Using the Elastic Client package, we can send more data to the Elastic server by using the update.doc function. We create an HTTP transport using the Elasticsearch endpoint. Unlike local hosting Elasticsearch, we will need to include the password and username we retrieved earlier. Before I input any data, it is important to know that our Elasticsearch index has a special mapping that is used for the n-gram search technique. To implement this, I can just use the update index function. I would input the index name and the mapping data I showcased earlier. Get the data we want to send from our text field widget and use the update.doc function to send the data to the Elasticsearch server. This is all we need to do to send the data on the client side. It is fast and simple compared to the cloud functions method. To finish the search feature for our Flutter application, all I would do is use a search delegate to showcase our search results. We start an HTTP transport again using the Elasticsearch endpoint, our username, and the password. Next, we will use the search method to search for some particular information. The search query requires an index, a type, and our search query. As you can see, we have our autocompletion set up, and we can search for any data we want. Like I ended my last video, Elasticsearch is amazing, and it is filled with so many settings that you have the choice to create your own Elasticsearch environment the way you like it. Please read the documentation for more information. If you would like to see more videos like this, do not forget to leave a like, comment, share, and please subscribe to the channel. Stay safe, everyone.